Next problem is let fn denotes the number of different ways in which the positive integer n can be expressed as the sum of ones and twos. For example, f of 4 equals to 5. Since 4 we can do as 2 plus 2 equals to 2 plus 1 plus 1, or 1 plus 2 plus 1, or 1 plus 1 plus 2, or 1 plus 1 plus 1 plus 1. So these are 5 ways. Note that order of ones and second is important. So based on this paragraph there are three problems. First is the value of f of 6 is. Now solution. So first is what? The value of f of 6. So f of 6 is what? Representation of 6 in summation of ones and twos. So representation of 6 we can do by, if we use 1 6 times and 2 0 times. So 6 times 1 we can write as what? 1 1 1 1 1 1. That is 1 ways. Or if we use 1 4 times, 2 1 time. So this we can write as what? 1 plus 1 plus 1 plus 1 plus 2. So this we can do by 5 factorial divided by 4 factorial, that is 5 ways. Because 2 can come at any place. So here order is important. We can write 2 plus 1 plus 1 plus 1 plus 1. This will count as different. So that is 5 ways. Or if we use 1 2 times and 2 2 times, like 1 plus 1 plus 2 plus 2. So this is 6. So this we can write as what? 4 factorial divided by 2 factorial 2 factorial. So this will come out 4 into 3 into 2 divided by 4. That is 6 ways. Or if we use 1 0 times and 2 3 times. So this will be what? 2 plus 2 plus 2. That is 1 ways. So total is what? 1 plus 6 plus 5 plus 1. So 1 plus 5 plus 6 plus 1. So this will come what? 13 ways. So option B is correct. Next problem is the value of f of 6 is. So f of 6 is what? 13. So we have to find out f of 13. F of 13 is what? Number of ways of writing 13 in terms of summation of ones and twos form. So 13 we can write as what? If you use ones or twos. So if I write 13 ones or 0 twos, that is 1 ways. So if you use 1 11 times and 2 1 times, so total is what? 12 factorial divided by 11 factorial, that is 12 ways. This is if I use 1 9 times and 2 2 times, so number of ways what? 11 factorial divided by 9 factorial into 2 factorial. This will come what? 11 into 10 divided by 2. So this will come what? 55 ways. Same way, if I use 1 7 times and 2 3 times, so total is what? 10 factorial divided by 7 factorial into 3 factorial. This will come what? 10 into 9 into 8 divided by 3 into 2. So 9 divided by 3 is what? 3. 8 divided by 2 is what? 4. So this will come what? 120 ways. Same way, if I use 1 5 times and 2 4 times, so total is what? 9 factorial divided by 5 factorial into 4 factorial. So this is what? 9 into 8 into 7 into 6 divided by 4 into 3 into 2 into 1. So 3 into 2 is what? 6. 8 divided by 4 is what? 2. So this is what? 18 into 7. So this will be 126. Next one is what? If I use 1 3 times and 2 5 times. So total number is what? 8 factorial divided by 3 factorial into 5 factorial. This we can do what? 8 into 7 into 6 divided by 3 into 2. So 6 getting cancelled. 8 into 7 is what? 56. Next is if I use 1 time and 2 6 times. So this will be what? 7 factorial divided by 1 factorial into 6 factorial. This becomes 7 ways. So total is what? 7 plus 56 plus 126 plus 120 plus 55 plus 12 plus 1. So this will come what? So F13 equals to sum of number of ways, that is 1 plus 56 plus 126 plus 120 plus 55 plus 12 plus 1. So this will got 1 plus 12 plus 55 plus 120 plus 126 plus 56 plus 1. This will come 377. So C is correct. Next problem is F n2n is first option is 1 1 and on 2, second is 1 1 and into, third is many 1 and on 2, and fourth is many 1 and into. So for solving this one, we have to find out f of 1. So f of 1 is what? 1. That is one way. Similarly f of 2. So f of 2 we can add what? 1 plus 1 or 2. That is two ways. Similarly f of 3. So f of 3 is what? 1 plus 1 plus 1 or 1 plus 2 or 2 plus 1. That is three ways. Similarly f of 4. So f of 4 is what? 1 plus 1 plus 1 plus 1 or 1 plus 1 plus 2 or 1 plus 2 plus 1 or 2 plus 1 plus 1 or 2 plus 2. So there are 1, 2, 3, 4 and 5 ways. So f of 5 also we can find out. F of 5 is what? 1 plus 1 plus 1 plus 1 plus 1 or 1 plus 1 plus 1 plus 2 or 1 plus 1 plus 2 plus 1 or 1 plus 2 plus 1 plus 1 or 2 plus 1 plus 1 plus 1 or 1 plus 2 plus 2 or 2 plus 1 plus 2 or 2 plus 2 plus 1. So this is what? 1, 2, 3, 4, 5, 6, 7, 8. So f of 5 is what? 8. So we can say f of 1 is 1, f of 2 is 2, f of 3 is 3, f of 4 is 5 and f of 5 is 8. So if we increase n value, then f of n is increasing. So f is 1 1. Second thing, f of 4 is what? 5 and f of 5 is what? 8. There is 6 and 7. So we are not getting 6 7. So we can say f is into. So B option is correct. 1 1 and into. Next problem is if n is the number of ways in which three distinct numbers can be selected from the set 3 power 1, 3 power 2, 3 power 3, dot, 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 3 power 10 so that they form a GP, then the value of n by 5 is. Now solution. So we have to select three distinct numbers from the set 3 power 1, 3 power 2, 3 power 3, dot, 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 3 power 10 so that they form a GP. So we have to select three numbers from this set. So three numbers will be in the form of 3 power A, 3 power B and 3 power C, where A, B, C belongs to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now these three numbers should be in GP. So we can say 3 power B whole square equals to 3 power A into 3 power C. This we can add 3 power 2B equals to 3 power A plus C. So we can say here 2B equals to A plus C. That means we can say ABC should be in AP. So ABC are in AP, that means A plus C should be even. That means A and C both even or A and C both odd. So A and C are both are even, that means we have to select A and C from 2, 4, 6, 8 and 10. So out of 5 numbers we have to select 2 numbers, that is 5C 2 ways. Plus A and C both are odd. So we have to select A and C from 1, 3, 5, 7 and 9. So out of 5 numbers, we have to select 2 numbers, that is 5C 2 ways. So this comes 2 into 5 into 4 divided by 2 into 1. 2 getting cancelled. 5 into 4 is what? 20. So we can say n equals to 20. So n by 5 is 20 by 5, that is 4. This is your answer. Next problem is, if n is number of necklace which can be formed using 17 identical pearls and 2 identical diamonds, and similarly m is number of necklace which can be formed using 17 identical pearls and different diamonds, then solution. So we have 17 identical pearls and 2 identical diamonds. That can be done if you put 17 identical pearls on a circle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. Now if you put 2 identical diamonds between 17 identical pearls, that divides these 17 identical pearls into 2 parts. So one part is having x1 identical pearls, other is x2 identical pearls. So we can say x1 plus x2 must be equals to 17, where x1 is greater than equals to 0 and x2 is greater than equals to 0. If x1 and x2 change, we'll get different necklace. So solution of this equation is what? 17 plus 2 minus 1 c 2 minus 1. This will become what? 18c1. So there are 18 ways. Now if we have 7 identical pearls and 2 different diamonds, so there are 7 identical pearls and 2 different diamonds. So total number of ways, here we have 7 identical pearls. If we put 2 different diamonds, so one is blue, other is red. So this divides these pulses in 2 parts, x1 and x2. So this will what? x1 plus x2 we can say 17, where x1 is greater than equals to 0 and x2 is greater than equals to 0. So from there we will get 18c1, that is 18 ways. Now, so these 2 diamonds can interchange by 2 factorial ways. So if we interchange these 2, so we'll get, there are 17 identical pearls and blue will come this side and red will come this side. Now if we flip this one, we will get this one. That means clockwise and anti-clockwise are same. That means we have to divide with 2 factorial. So what will get? 18 ways. So this is your answer. So m and n both are 18.